all the data you'll see today is generated by one of our systems or has gone through our software. We are based on active stereophotogrammetry, software-driven systems, and we capture everything in the visible light spectrum. So here we are inside one of our systems. This is a 3D body system. There are 84 machine vision cameras in this system from 28 viewpoints. Each of the viewpoints has a single color camera and a pair of stereo monochrome cameras. Here we're capturing our subject at 60 frames per second, and we captured 5 seconds of data, giving us 300 frames. We then reconstruct those frames, the 3D surface, overlay the texture map, and then we can play that back in our software. So the output of this, of what you see, is a real-world, near-ground truth anatomical shape information for every single frame in that sequence. The data from our body systems maintains this rich set of data. And we can capture the hands and the face in the context of the body in detail, so much so that we can actually simultaneously track body pose, hand pose, and a set of facial features throughout the entire sequence of data on the same piece of data in the same piece of software. So here we are able to fit the skeleton to every single frame in the sequence, and then we can look at how the body shape might change as you perform certain actions. So in this instance, he's just checking the time on his wristwatch and pulling his cell phone out of his pocket. So we can look at how the forearms change shape. We can use markerless tracking to track features on the face, and then we can use that to derive a homologous mesh of the head and the face that captures those facial expressions. But if you want to use that data to train machine learning or to do facial animation, you might want to be able to remove the eyes and the mouth. So that's one of the things that we've been working on, is a way to cleanly remove the eyes and the mouth from the data while retaining all of the facial expression information in that derived mesh. All the metadata that's generated by the analysis software, actually all the measurements, all the dynamic information, all of that can feed into the database, and then that becomes searchable and usable for downstream applications. We want to generate all of this extra metadata, and it would be great if the next generation of file formats was able to encapsulate this data, so you didn't have these fragmented files everywhere, and so you have to, take the surface and the texture map and then all the analysis that you generate. All of that, find that way into a single file that is an open file format that has some standardization for it so that it can be opened up in multiple applications.